Hi guys, we sincerely appreciate you for your support and solidarity towards the common good of this great family of mathematicians. God bless you. Now today let's look at this topic, coordinate geometry. Now suppose there are 2 points P and Q on a line such that the coordinates of points P and Q on the Cartesian plane are P is on coordinates x1, y1 and Q is on coordinates x2, y2. Now, these 2 points, when represented on the Cartesian plane, is this. Okay, now, this is the y coordinate and this is the x coordinate. Okay, now, if the line connecting P and Q is this line, and we have the 2 points, this is a point P and this is a point Q. And point P is on coordinates x1, y1, while Q is on coordinates x2, y2. All right, now it is now very possible to characterize the geometrical properties of the line connecting P and Q in the context of the following subheadings. Now, the first parameter we're going to look at is the gradient of a line. Now, the gradient of the line connecting P and Q is given by the formula y2 minus y1 divided by x2 minus x1. Now, the next we're going to look at is the equation of a line. Now, the equation of a line connecting the 2 points P and Q is given by y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. All right. Now remember that y2 minus y1 over x2 minus x1 is the gradient of the line. So the equation of the line connecting the 2 points is obtained by equating the gradient to this very parameter. Then whatever you get there is the equation of the line. Now, the next we are going to look at is the midpoint of a line. Now, the midpoint of a line is the center of the line PQ. All right, and that midpoint is given by the formula x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, that is the midpoint of the line segment PQ. And finally, we're going to look at the distance between 2 points. Now, the distance between 2 points is simply the length of the line segment connecting the 2 points on the Cartesian plane. And that distance is given by the formula the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, now let's use just an example to illustrate what we are talking about. Okay, now suppose we have 2 points P and Q such that P is on coordinates 2, 5 and Q is on coordinates maybe 6, 8. Okay, now let us use these 2 points to drive these concepts home. All right, now the first thing we're going to look at is to bring out the various parameters, that is x1, x2, y1, y2. Now, from here now, x1 is equal to 2 and y1 is equal to 5. Okay, now x2 is equal to 6 and y2 is equal to 8. So now, when we're asked to find the gradient of the line connecting P and Q, the gradient is equal to, from our equation, y2 minus y1 over x2 minus x1. Okay, now, and this is equal to y2 is 8 minus y1 is 5 divided by x2 is 6 minus x1 is 2. And this is equal to 8 minus 5 will give us 3 divided by 6 minus 2 will give us 4. And this is the gradient of the line joining P and Q on the Cartesian plane. I hope you are getting it. All right. Now, let's look at the next parameter. That is the equation of a line. Okay. Now, the equation of a line connecting P and Q is given by the formula y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. But remember that y2 minus y1 over x2 minus x1 is the gradient, and we have gotten the value as 3 over 4. So we're going to substitute the value there. So we're going to have 3 over 4 is equal to y minus y1 is 5 divided by x minus x1 is 2. Okay, so now when we cross multiply, we are going to have 4 into y minus 5 is equal to 3 into x minus 2. So when we expand these brackets, we are going to have 4 times y is 4y minus 4 times 5 is 20 is equal to 3 times x is 3x minus 3 times 2 is 6. All right. So now when we transfer minus 20 to the right hand side of the equation, we are going to have 4y is equal to 3x minus 6 plus 20. All right. So now 4y is equal to 3x. Now minus 6 plus 20 will give us 14. Now, the equation of the line connecting P and Q is obtained by dividing both sides by 4. That is the coefficient of y. So y is equal to 3 over 4x plus 14 over 4. And finally, it can be reduced to y is equal to 3 over 4x plus 7 over 2. And that is the equation of the line connecting P and Q, where 3 over 4 is the gradient. And that is the value we got here. And 7 over 2 is the intercept, C. All right. Now let's look at the next, which is the midpoint. The midpoint of the line joining P and Q. Now the midpoint, that is the center of the line PQ, is given by the formula x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, now, when we now substitute the values, this is equal to x1 is 2 plus x2 is 6 divided by 2, comma, y1 is 5 plus y2 is 8 divided by 2. All right, and this is equal to 2 plus 6 is 8. So we have 8 divided by 2, comma. Now 5 plus 8 is equal to 13 divided by 2. And finally, 8 over 2 is 4, comma, then 13 over 2. And this is the midpoint of the line joining P and Q. All right, so finally, let's look at the distance between the 2 points P and Q. Like we said before, It is simply the length of the line segments connecting P and Q on the Cartesian plane. All right, so now the distance PQ is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, and this is equal to the square root of x2 is 6 minus x1 is 2 all squared plus now y2 is 8 minus y1 is 5 all squared. Okay, now this is equal to 6 minus 2. 6 minus 2 will give us 4. So we have 4 squared plus 8 minus 5 will give us 3. That's 3 squared. Alright, so this is equal to the square root of 4 squared is 16 plus 3 squared is 9. And this is equal to 16 plus 9 is 25. And the square root of 25 will give us 5. So the distance PQ is equal to 5 units. Alright, hope you enjoyed our lectures. Thank you so much for your audience. Please try to share our videos and subscribe to our YouTube channel. God bless you.